Buildings are composed of rooms. Although buildings and rooms have slightly different functions, we essentially treat them as generic housing structures. You can enter and exit a building or a room, and they can both be used to store furnishings. So, despite being unique types of objects, they can be dealt with uniformly. The composite design pattern achieves two goals: to compose nested structures of objects, and to deal with the classes for these objects uniformly. The pattern follows this basic design. A component interface serves as a supertype for a set of classes, so that they can all be dealt with uniformly. This is done by enforcing polymorphism. All implementing classes conform to the same interface. An abstract superclass can also be used in place of an interface, as both are allowed for polymorphism, but we'll focus on using an interface here. The composite class is used to aggregate any class that implements the component interface. The composite class will allow you to traverse through and potentially manipulate the component objects that the composite object contains. The leaf class represents a non-composite type. It is not composed of other components. Next, we want to deal with non-composite and composite objects uniformly. By having the leaf class and composite class implement the component interface, we unify them with a single type. The composite and leaf classes are now considered subtypes of component. Depending on the problem, you can have other composite and leaf classes when using the composite design pattern, but only one overall component interface or abstract superclass. Note that a composite object can contain other composite objects, since the composite class is a subtype of component. This is known as recursive composition, which is another name for this design pattern. It can be difficult and confusing to imagine how this design pattern actually looks like because of the apparent cyclical nature of the composite class. The easiest way to visualize it is by thinking of it like a tree. At the root level, we have our main composite object, which is made up of other component objects. At each level, we can add more components below each composite object, like another composite or a leaf. Note that you can only add components to a composite object and not a leaf object. This means that a composite object has the potential to grow the tree, while a leaf object effectively ends the tree where it is. The composite design pattern is used to address two issues. How do we use individual types of objects to build a tree-like structure? And how can we treat the individual types of objects uniformly without checking their types? Now that we know what the UML class diagram of a composite design pattern looks like, and how to interpret it, let's apply it to an example. We will use the earlier example of how buildings are composed of generic housing structures. This structure is considered the component interface. It can be used to describe a building, a floor, or a room, despite each of these being unique types of objects. The housing class is the composite class. A housing is a type of structure which could also contain other structures. This means that a housing object could contain other housing objects. For example, a building could be represented by a housing object, and the building could contain floors. Each floor could be represented by another housing object. We can traverse through the building from floor to floor because the building is composed of floors, all of which are housing objects. A room is considered a leaf class, since a room cannot contain another room. It is contained within a housing, like the floor of a building. We now have a UML class diagram that expresses how to model buildings being made up of housing and room types of structures. Next, let's realize the composite design pattern for the building example in Java. Step 1. Design the interface that defines the overall type. We start off by defining the interface that the composite and leaf classes will implement. This supports polymorphism for your component and leaf classes. Step 2. Implement the composite class. You implement the interface in the composite class. This will give the housing class its own behavior when client code uses it. Since a housing object can be composed of other structures, you will need to represent this containment with a suitable collection. You will also need a method for adding more components to your composite object. Here, we have used a private array list and changed it only through the public addStructure method. To traverse through the components of a composite object, you must be able to retrieve the components when asked. You can also include additional methods which will help with the management of component objects. It is up to you to decide what else to include in your composite class. Step 3. Implement the leaf class. Since the leaf class doesn't contain any components, we don't need to add a collection of components to it or any methods to manage a component collection. We simply need to implement the methods of the iStructure interface. Now that we've finished implementing our building using the composite design pattern, how do we actually use it? We simply construct our building structure by structure. In this example, our building has one floor, which contains a common room and 2 washrooms. This is obviously very simplistic, but it gives you an idea how powerful this design pattern can be. Composite objects can be built quickly and easily. Each component can be expected to have the same set of behaviors without needing to do any type checking. To summarize, the composite design pattern is used to solve the issues of how to build a tree-like structure of objects, and how to treat the individual types of those objects uniformly. This is achieved by enforcing polymorphism across each class through implementing an interface, or inheriting from a superclass, and using a technique called recursive composition, which allows objects to be composed of other objects that are of a common type. You can think of this design pattern as applying the decomposition and generalization object-oriented design principles together to break a whole into parts, but having the whole and parts both conform to a common type. The composite design pattern lets you build complex structures by constructing them using composite objects and leaf objects, which belong to a unified component type. This makes it easier to understand and manipulate the structure, and will lead to more readable, reusable, and meaningful code.